In our previous session, we have discussed about the page concept like what is the database architecture, and we have discussed the database is a combination of MDF and LDF. And we have discussed about MDF in our previous session, and today we are discussing about our transaction log file. And here, actually, what is a transaction log file and why do we require transaction log file? We'll be discussing about this concept here, and architecture of log file, and how the data is being, how the transactions are being stored in transaction log file. What happens if the transaction log file size increases? How will be how the impact will be on the how the performance impact will be on the impact. How does the impact will be on the production or on the server if the transaction log file grows, and how can we protect the log file, and what is VLF, and how does the log file behaves in different kind of recovery models. We will cover all these concepts and today. Okay. See here, what is saying transaction log file, and a transaction log file, as we have already discussed, that database is a combination of MDF and LDF. Here we are calling LDF as a transaction log file, or log data file. We can call it as .ldf. Some people will be calling. Each and every transaction that occurs in the database will be recorded in the transaction log file. Each and every transaction, not only anything that happens on the database will be tracked, will be logged into the transaction log file. As we have discussed in our database architecture, SQL Server architecture session, we have discussed that log manager will assign a LSN number to each and every transaction that occurs in the transaction. For each and every log file, each and every log transaction, we will be having a unique LSN number. LSN means log sequence number. A unique LSN number we are having for each and every transaction. For each and every transaction, we are having a unique LSN number for each and every transaction. LSN in the sense log sequence number. See here, log records are the core of logging and recovery mechanisms. It means like whenever if any disaster occurs, or if any network failures occurs to the production abruptly, to our servers abruptly, then in that case we need to have some recovery scenarios. Like, see, I'm having a backup, or I'm having a restore point till 10 a.m. But my log file crashed, my server crashed at 10:15 a.m. But in between 10 and 10:15 a.m. there is no log backup schedule. It's in our maintenance plan, or we're not having any log backup schedule, and there is no way to recover our database transactions. So in that case, if we are having a log backup, or if we are having a log file, in that cases also we can recover our transactions by using some recovery mechanisms like a rollback and a roll forward. It means like what happens in that case is the uncommitted transactions will be rolled back. If there is any disruptions in the database, in the production or in our server, if there is any disaster occurs, while it is going to offline, it will roll back the uncommitted transactions and it will roll forward. If there are any committed transactions in the log file, it will commit those transactions to the disk, and uncommitted transactions will be rolled back. Log file is very important, and it plays a major role in our database, in our database, because each and every transaction will be stored in this log file, and it also plays some key roles in high availability concepts, like I think you're aware or not, but these are high availability concepts we are having. In our high availability concepts like log shipping, mirroring, replication, and always on. Log file plays a key role in those kind of high availability concepts. In our future sessions, or in some after some sessions we'll be coming to this high availability concepts. No need to worry about it at this point of time about that. Okay. And then if there is any performance in performance bottlenecks with respect to the log file, it impacts the performance of our server in a huge manner. That means if my log file has been grown until to its maximum size and the incoming transactions are not coming, the data flow will be stopped. Incoming transactions are not coming, data flow will be stopped. Such a huge impact we will be having with the transaction log file. And we can also say the transaction log is probably the most part of SQL Server, because without the T.Log or transaction log, you're not able to have the transactions that can be made durable. Because if any crash occurs, then you will be able to recover the transactions just by using rollback or roll forward mechanisms. What the transaction log file will do is it keeps track of all the database changes, and every change is written into the log file first before writing into the disk or MDF. Every change is written into the log file first. See here, SQL Server Database Engine is a combination of MDF, NDF, and LDF. MDF is metadata file, primary file, and LDF is log data file. This is NDF, secondary data file. In some huge transactions, if a database is having huge transactions, in that cases, we'll prefer this NDF, secondary data file. MDF will be one, LDF will be one, and in 95% scenarios, LDF will be one, and NDF, secondary data files, can be many. In 5% scenarios only, LDFs. It means like not only 5%. I am not saying like it's not like a percentage criteria here. Means like most of the databases like GIS applications or multimedia applications, those people will be using multiple log files. Most of the cases we will be having only single log file, and MDF can be many, but MDF will be only one. Here the difference between MDF and NDF is MDF, metadata file, it contains metadata and the user data. But in NDF, secondary data file, it contains only secondary user data. In secondary data file, we will be having only user data. In MDF, metadata file, we will be having user data plus metadata. And in LDF, we are having only transactions. See, in this session, we are going to cover these points like log file architecture, working with VLFS, dealing with full log, likewise, and log file growth and impacting the performance. How the log file, if the log file grows, how it impacts how the performance impact will be on the server. And at the end, we will discuss about new features, some 2 to 3 new features in 2014 and 2016. We'll be discussing about these new features with respect to log file, and we will also I'll also show you how does the log file grow will happen, and what kind of states it will show practically. Log backup, database mirroring, nothing, active transactions. If the log file grows, by using some commands, we can diagnose the things. I'll show you all those things practically in this session. Okay, this is a log file architecture. In database, we are having data file MDF and transaction log file LDF, and this is a plan cache. This is a data cache, and here also we'll be having one portion called log cache. Log cache. It is not written there. There is one portion called log cache here also. Okay, and see here SQL Server transaction log is saying. What transaction log file is doing is it is dividing the transactions into some smaller portion of chunks, small chunks called as into chunks called as VLFs, virtual log files. Here, see, virtual log 1, virtual log 2, virtual log 3, virtual log 4, virtual log 5. See, we cannot decide the size of number of VLFs that needs to be generated depending upon our transaction. It generates the VLF, but we cannot decide that only these many VLF should be generated and that only these number of VLF should get generated to this transaction, and the maximum number of VLFs we cannot fix. See, we have already discussed that for each and every transaction we will be having LSN, but for each and every VLF we will be having min LSN. See here, min LSN. And see, these VLFs will be in cyclic and wrapping nature. It means like VLF1, VLF2, VLF3, VLF4, VLF5. If these gets truncated, those will be used again. See, VLF1, VLF2, VLF3, VLF4, and these are recycled again. See here. We will discuss about this in detail now. Okay. And by going into the deeper architecture of this VLF architecture also, see here, virtual log file 1, virtual log file 2, virtual log file 3, virtual log file 4, virtual log file 5 we are having. These are states in VLF we are having: inactive, active, unused, and reused, and passive. Reusable or passive we are having. The states in VLF we are having. Different states in VLF we are having. It means like active VLF in a sense. Here, this VLF is having some transactions. Those are not written to the flush to the disk. Okay. Inactive or unused VLF means these VLFs can be reused. Those are empty, we are saying. It means like the transactions are flushed to the disk. And another type of VLFs we are having, those VLFs like passive or reusable and recoverable VLFs. Passive or reusable VLFs, in the sense we can say that those VLFs are ready to reuse. Okay, and each and every VLF is having some blocks. See, this is one block, 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 another block. Okay, and these block sizes varies by starting from 512 bytes to and the maximum size of block is 60 KB. Okay, and these blocks can have multiple records in it and multiple transactions. All the transactions are intermingled here. See here, I'll show you an example. I'll show you practically. I'm saying create table EMP. I'll not execute this. I'll just show you practical in the diagram. Okay, and I'm trying to insert. I'll try to insert 4 rows here. I'll try to insert 4 rows here. Trying to insert 4 rows. These are all 4 transactions I need to say. Okay. When I try to insert 4 transactions, see here, what is saying? This block contains and this record contains multiple transactions. All the transaction one related records here, and all the transaction two related records here, and the transaction three related records are here. Okay. By differentiating the color, he is trying to distinguish. Okay. See, nothing is complicated here. Just we have to analyze it. Log file will have will store the transactions. Will store the transactions in the form of small chunks called VLFs. Means like it will split the transactions into small chunks called VLFs, and that VLF will be having some states like active, inactive, active VLF, inactive VLF, unused or reusable VLF, or passive VLF. Active VLF, in a sense, we can say that active VLF, in a sense, we can say that it is having some transactions, and inactive or reusable VLF, in the sense, we can say that it is not having any transactions in it, and it can be reused. He is saying that it can be reused. And reusable VLF, in the sense, uh, it is about to reuse. It is about to reuse. A reusable VLF, in a sense. And again, VLF is being divided into, it means like is being split into blocks, and each block size differs from the minimum size of block is 512 KB, and the maximum size 512 bytes, and the maximum size of a block is 60 KB. He is saying, okay, and we can also have intermingled or multiple transactions in a block. We can also have multiple transactions in a block. Not only each block contains like transactions related to records related to one transaction and another transaction. We can also have multiple intermingled transactions in a block, in a record. Okay, and here, see here what he's saying again. Log records for concurrent transactions are intermingled in the transaction log according to when they occurred in time. Okay, here we have seen intermingled transactions. Not only this, all the transactions are being executed only in one record. Log records are stored in log blocks in the buffer pool until they are flushed to disk. Log blocks, in a sense, the buffer pool, they are stored in log cache. See here, in log cache, they will store until they are flushed to disk, is saying. Okay. See, he's saying, right, they are flushed to disk, he's saying. But if before flushing to disk, we may have transactions with respect to two different kinds, like committed and uncommitted. What is the behavior of committed transactions and what is the behavior of uncommitted transactions? We are going to see here. If all the changes, updates are completed, transactions can commit. If not so, they cannot commit. And see, I am executing a query, select star from EMP, which is having 1,000 rows in it. And it may take some 2 to 5 seconds or 2 seconds to execute the transaction. In meanwhile, if there are any transactions that are coming into the database or any changes that are coming into the database and a new transaction occurs, that transaction may occur within milliseconds, but this transaction may take some 5 seconds. Until this commit happens, all the rows get executed, until all the rows are retrieved from my database, this query will be in executing process. It means like until that execution process completes, my transaction was not yet completed. Okay, he's saying the same. If all the changes if all the changes, updates are completed, transactions can come in. Ensure that all the transaction log records generated by the transaction are forced to the T.Log file on disk. Whatever the transactions that are recorded on the transaction log, or forced to T.Log file and also onto the disk. Okay. If all the transactions are committed, then it will show as LOP commit rank. In some cases, I'll show you practically all these things now. Okay. All logs are released held by the transaction once committed. It means like logs in the sense. When I say select star from EMP, there is a shared log that occurs on the table because shared log. There will be a shared log that occurs on on the same table EMP. If I say select star from EMP, it means until this 2 to 3 seconds, and until my transaction gets executed, this 2 to 3 seconds, no other user cannot retrieve the information from the same table to maintain some concurrency, to maintain some consistency. SQL Server will apply these locks on the same table until one user transaction gets committed. We will also discuss about these lock mechanisms in our performance tuning sessions. Okay. There are many locks that occurs in our database. We will discuss about this. Okay. Just for our understanding, I'm saying all logs are released held by the transaction once the transaction gets committed. Okay. And how the T.Log flush, here he is saying that log records are stored in log blocks in the buffer pool in a smaller portion called log cache. Okay, log cache. They are flushed to disk. See here how the T.Log is flushing into the disk is showing. It means into log cache. Okay, virtual log file and log blocks. Okay, and these records are flushed to log cache. See here, log cache is capable of holding 128 log blocks, he's saying, with its maximum size of 60 KB. It means 128 into 60 KB is my log block size, log cache size. It can handle up to that amount of log blocks. 128 into 60 KB with its maximum size, he is saying. Okay. It is having a capacity to store that much uh, size of log blocks. Okay, as per the database. Until it means like until the 128 log blocks enter into log cache, it will not keep that all log blocks in the log cache itself. It will flush this log blocks into the disk again. Okay. So what it will do is this log cache will flush all these log blocks recurringly into the disk again. It will intake the log blocks and it will throw the log blocks into the disk again. The transaction happens recurringly, it will not stop, but it is having a capability to handle 128 log blocks. Means it is having a storage capacity to have 128 log blocks with its maximum size. Means with its maximum size in the sense 60 KB is its maximum size. 128 into 60 KB is the storage capacity of log cache. Indirectly is saying per one database. With respect to another database, again we can have 128 into 60 KB log blocks in a log cache. For each and every for each and every one database, we will be having 128 log blocks in the log cache. That is the storage capacity of log cache in our database is saying. This is with respect to the transaction commit. Okay. What happens if there is uncommitted transactions and if there is any disaster occurred, and at that point of time uncommitted transactions should get rolled back and the committed transaction should roll forward. Okay, what happens here is while committing a transaction, SQL Server uses first in first out mechanism, but while uncommitting a transaction or while rolling back a transaction in the T.Log, it uses a mechanism last in first out. Okay, see here VLF3, VLF2, VLF1 about log record. In this scenario, it will delete the transactions. Okay, and if there is any case like committing a transaction, it will use VLF1, VLF2, VLF3. In this case, see here we have seen here. it is such a the scenario will be like this. If there is any rollback transaction, the scenario will be like this. See, he's asking, what happens? See, we are having a transaction log file, and a transaction log file architecture. It contains VLFs, and VLF contains log blocks, and log blocks contain some records, and these log blocks are written or moved to the log cache, and from there they are moved to the disk you're saying, and your log cache is also having capacity to store 128 log blocks with it, with the maximum capacity like 128 into 60 KB of size, the storage capacity of log cache you are saying. But what happens if my transaction log file gets filled completely? The complete transaction log file was filled and there are no incoming transactions are stopped in my database. What happens in that case? How can I diagnose these kind of things? What is the root cause? What should I do? Where can I identify? How can I identify whether my transaction log file get filled, or what is the reason that incoming transactions are not coming into my database? To find all these kind of things, we are using a command called dbcc sql perf log space. See, I will execute this and show you how can we see my log file capacity. Okay, sorry, this is a spelling mistake. Execute. See, I am in demo database. My log file size is 215 MB and my log space used is 100%. My log file got filled in this case. See here, log test. My log size, I'll execute the same command. Log test is 8 MB and the used percentage is 6 MB. Okay. And what is causing, what is the reason that my log file, I'm not getting income, I'm not being able to see incoming transactions in my database? What is the reason? What happens to the database? What happened? What was happened to my log file? We can see here by using this command, we can see what is the problem with my log file, why it is not allowing, why it is not allowing any kind of incoming transactions into the database. What is the reason? It displays the reason here. See, what it is showing with respect, I'll show with respect to two databases. Log test is of 8 MB size and 6% it was used. What it will show you, see now. See, log test, it is saying nothing. Nothing has happened to your data, your log file. You can do the transactions, incoming transactions can happen. He's saying. What happens? See here. If I execute the same command with respect to the demo database, which is 100% filled, what it will show you, see now. See, you have to take log backup. Your log file is completely filled. If you take log backup only, the incoming transactions will be allowed. It is same. Okay. In place of log backup, here you will also have database mirroring, comma, replication. Some cases like always on AAG also you will have. I'll show you what in what cases this happens. In what cases we will show you practically. We are having a Microsoft document further. I'll show you elaboratively in what cases like Yes, we'll see here. Log reuse by description. See here. Sorry. See. See here he's saying log backup, active backup or restore. If there are any active transactions that are if there are any active backup or restore activity as being happened, then also it's like I am taking a backup of 10 TB size of database. It may take more than 2 to 3 hours. In that case also it will show like active backup or restore, so that until that your log file will not have incoming transactions. Either you have to kill that process or you have to do that activity in some time period in another time, like where when you will have some your business activity will be very slow. Okay, the incoming transactions in your database will be very slow, low incoming transactions. And active transaction we are having, and as in database mirroring, I'll show you practically in my database mirroring session also. With respect to unsent log file, if you are having unsent log file, then it will say database mirroring. In if you are having, there is a disconnected state in principal and mirror, you will not understand that concept. Now I'll let you know that about the completely in replication, database snapshot creation, log scan, always on availability group, and other consistent for internal use, only for internal use, oldest way. And this is the HTTP checkpoint. When a database uses a recovery model, has a memory optimized data file group, you should expect to see the log reuse wait column indicate checkpoint or HTTP checkpoint. He said. In these kind of scenarios, in these 16 scenarios, your log file will stop the incoming transactions if you're having some problem. These kind of problems with respect to your log file will stop the incoming transactions. Okay. What is the root cause? He said. My log file got filled. That what is the root cause? Other than I'm having log backup, then I'll take log backup. Then also my log file issue is not being solved. Means like my log file did not release any space. I have taken log backup. Then also it is not releasing any space. Then what should I do? See, if it is shows take log backup, take T.Log backup. In that case, some amount of space will be released. You're taking T.Log backup, and if there is a scenario like this, my log file, my log backup is coming into D drive. My restoration, my storage point is D drive. D drive backups, log backup. I have given some specific path to take log backups. My D drive got 100% full. I'm not being able to take log backup. What happens in this case, in this kind of scenario? In this kind of scenario, you will not being able to connect to the database. The transaction log file got filled. Your database will go into suspect mode. There is the only solution in that case is you need to add some space to the drive. Nothing you can do here. If you're having some amount of space, and if you're having some amount of space, you can take the log backup or you can shrink the log file. Shrinking means it releases some amount of space. Which I'll tell you what happens, what does shrinking will do and what does truncate will do. Just in a couple of minutes, I'll tell you. Or another solution is add some disk space so that uncommitted transactions will roll back. Okay, if it is going into suspect mode and if it is coming before going into aspect mode, what happens is it uncommitted the transaction. The disaster occurred, the uncommitted transactions will roll back and the committed transactions will be rolled forwarded. What he's saying, add some disk space so that uncommitted transactions will roll back, and then you will find some more amount of disk space to take a log backup. Or else there is only solution that change the drive or location of the log file where the disk space is available. But in a case you're not being able to connect to the database, in that case you are not having any option to change the log file drive location also. In that case, there is no chance you have to add the disk space. If you are having some 5% of the disk space, in that case only you have some you are able to recognize the issue with respect to the log file. Then in that case you can immediately change the location of your log file to another disk where you are having some space available. Let the transactions come into that come into another drive, and here in the previous drive you just clear the space, and then you can move the T.Log again into this your previous location until the issue gets resolved. Okay, and see how does the transaction log file behaves with respect to recovery models. We have not discussed recovery models till now. Just I'll let you know what is the recovery model and how does the log file behaves with respect to different kind of recovery models. Not elaborately, I'll just tell you in brief manner, and we are having another session on this recovery models. In that session, we will be discussing about the recovery models in detail again. Okay, we are having three types of recovery models in our database in our SQL: simple, bulk logged, and full recovery model. What is a simple recovery model? Every transaction that is completely written in the log file during the process, once committed, it means if the transactions are once committed, they are automatically will be flushed out to the disk, because in simple recovery model checkpoint will be enabled. Always the checkpoint will be enabled. The log file gets truncated immediately. Truncate in the sense, I told you now, the log file will be flushed to the disk. Truncate in the sense the log file will be flushed into the disk. The log file, log cache, what it will do is it will flush into the disk. Log records are stored in log blocks in the buffer pool until they are flushed to disk. In simple recovery model, if the transaction gets committed, the log record will be automatically flushed to the disk. But due to that reason only, you cannot take log backup in simple recovery model. In backup sessions, you will be completely knowing about this, but you can take a full backup. But in bulk log recovery model, what happens is you will be having a capacity to take ability to take log backups and differentials, but not point in time recovery is not possible here. Okay. And in simple recovery model also, point in time recovery is not possible. You will come to know about this point in time recovery and this log backups, full backup in our backup restore scenarios. Just to understand, you just keep in your mind that point in time recovery. Point in time recovery. It means like we are restoring our database. While doing a restore, we'll restore our database only with respect to some point of time, not all the complete restore will do by using this option. We are having some other mechanisms to restore the database, not completely restoring, only up to some extent of time. Okay. Log and differential backups are allowed in bulk log recovery model, and full recovery model. All the things are done here. It means like point in time recovery is possible, log backup is possible, differential backup is possible, log backup is possible, and everything. But the main difference you need to understand here is with respect to simple bulk log and full recovery models. In simple recovery model, what happens is truncate on checkpoint is enabled by default. So it will automatically flush the committed transactions into the disk. But in full and bulk log recovery model, unless you take a log backup, the transactions are not flushed to the disk. Okay. What are VLFs? Uh, what happens if I'm having some problem with respect to VLFs? What is the scenario? Here we are seeing working with VLFs. See, always a transaction log file should have VLFs that if my transaction is having some 100 rows to get executed, I'm saying select start from EMP. I'm trying to execute some 100 rows. Okay, my VLF should be equal to number of rows, 100 rows, or less than 100 rows, but it should not be greater than 100 rows. It's like my rows is 100, my row count is 100. Only 100 VLF should get generated, not much more than 100. If there are any VLFs that got generated more than 100, in that case we are having some performance problem with there is a certain performance impact with VLFs. Okay, see here what is saying, difference between truncate and shrinking is saying. Truncate, what it will do is, whenever a checkpoint occurs, we have discussed a checkpoint in our SQL architecture session. Checkpoint will truncate the log file. Okay, it will flush the data from log file into disk. Okay, whenever truncate happens, it means like whenever when we are trying to truncate the log file, it will just flush the log file into disk. Okay, and what happens here is, but with respect to full and bulk log recovery model, only whenever you take a log backup, then only log file gets flushed into the disk. But in simple recovery model, whenever a checkpoint occurs, the log file gets flushed into the disk. Okay. Difference between shrinking and truncating. What shrinking will do and what truncate will do. When I try to truncate the log file, if my log file size is 100 MB, log file size remains constant, 100 MB only. But what it will do is, it will free up the available space in the log file. See here, I had shown you DBCC SQL per log space. See, if I am trying to truncate the log file, my log file size remains same for this demo database as 215 MB. But what it will do is, the log space used will be freed here. The log space used will be, here it is showing 100%, but the log space used percentage will be decreased when I try to truncate the log file. But when I try to shrink the log file, my log file size will get reduced. Okay, are you clear? My log file size remains same when I try to truncate the log file, but my log file size will get reduced when I try to shrink the log file. Okay. If you are still having some problems after taking the log backups, after changing a recovery model, if you are having some problem with the log backup and there is some space available in your database, in that case you can change your recovery model from full to simple or bulk log to simple, because whenever you change the recovery model to simple, checkpoint occurs, and whenever checkpoint occurs in the simple recovery model, automatically log file will get flushed into the disk, and then your log file will release some amount of space. Okay. If there is any scenario that you are not being able to you are not being able to change the recovery model from full or bulk log to simple, then you're not having some enough space to do such kind of activity also. In that case, you have to take, there is only chance of taking a log, adding a disk space to the drive, or if you're having some 3 to 5% of space, in that case also you can take log backup. If you're not still having the disk space to take log back, even to take the log backup also, in that case, then there is no option that you should have After taking log backup also, you're not being able to release the space. In that case, you need to string the log file. And if you're not having if you're not getting any, if you're not getting any space released after syncing the log file also, then there is only one action that you have to perform. Is you just need to discuss with your application owner or with your customer and ask him to some with, not with your customer, sorry, ask your Windows team to add some disk space in your drive so that the issue gets resolved. The temporary disk space, ask them to add, and then after getting the issue resolved, then later you can deallocate that space. Okay, this is working with VLFs. Okay, see, see what it is. What he is saying is dbcc log info. This shows, this command shows your VLF hierarchy or your VLF structure. How many VLFs are generated? How many VLFs are there in my database? This command shows all the complete information. DBCC login. Sorry. See. We are in demo database right now. My demo database is having 17 VLFs. Okay, this is recovery unit ID, and this is file ID. LDF is 2, MDF is 1. MDF means metadata file, primary data file. LDF means log data file, T.Log. File ID of MDF will be 2 always. And this is the size of my VLF. This is just a row offset. It means like this row is like 203.1616 plus 812, 203.1616 plus 203. This is this, and this is this. Star offset, start offset will be cumulative with respect to each and every VLF. And this is a F sequence number, VLF number, status 2, active, parity 128, create LSN. Whenever the create LSN is having any number other than 0, it means auto growth was happened to your log file. Okay, I'll let you know about this auto growth also now. I'll show you practically all these things now. 64, 128, parity has been added. This VLF has been added again. In that case, the 64 becomes 128. See here, 37, create LSN is 37. It means like with respect to F sequence number 37, at that point of time, this auto growth was happened, it is saying. When your F sequence number was 45, at that point of time, this auto growth was happened. When your F sequence number was 56, at that point of time, 50, your auto growth was happened again. When your F sequence number was 71, again the auto growth was happened. In this, all these many cases, auto growth was happened here. By using this command, you can see what is the status of your VLF and all the things you can see. Okay. See, file size I have discussed now. VLF size in bytes, starting offset of the VLF in the transaction log in bytes, and it will be showing your cumulative. Cumulatively, it will add the disk space. Okay, add the space. It will just add the VLF size cumulatively, and it will show you in start offset. Okay, F sequence number is this is my VLF sequence number. Status 2 is I told you now whether the VLF is active or not. 0 means inactive, 2 means active, 1 is not used. Okay, parity, current parity bits 64 or 128 or 0 if the VLF has never been active. Your parity will be 0 if your VLF is not active. I have to use some text, I think so. Okay, let it be, I'll modify it later. Okay. And all other VLFs that are added after the initial creation of the transaction log will have non-zero create LSN. I told you, no? Okay. And another important point to remember here is whenever you create a database, at least one VLF will be with status 2. And another important point, two important points you need to remember with respect to log file. Status will be two for any one VLF. If it is a newly created database also, for one VLF, your status will be two. And another important point is that you will be trying to shrink the log file to 0 MB, but remember one thing, your log file will never come to 0 MB. It will just, sometimes it may have 128 MB or 64 MB a minimum. Your log file will never come to 0 MB of size. Okay, because it has some metadata in it, and always one active VLF you will be having in any database. Whenever you create a new database also, you will be having one VLF with status 2, saying as one VLF is active in your database. Okay. Examining the log records, we had seen this DBCC log info. Log records can be examined. This select star from DEF and DB log, it will not show you anything. See, I'll just DBCC log info is enough. It will just show you the LSN numbers, starting and ending LSN numbers. To retrieve this information, you require this select star from FND below. Select FND below. Okay. Sorry, I did not. See here. Current LSN it is showing. How many VLS? Oh, I'm having some. See, I had shown you, na? LOP commit ran in this PPT. See here, somewhere we have discussed like commit transaction commits. See, LOP commit ran. See here, LOP commit exam. The mechanism, it means like the operation that has been performed uh, in the log file, it is trying to write there. Okay. You can also see like DBCC log 0 means current database. You can see here with respect to demo you are executing this query. Okay. What happened to this? Oh, it is still executing. Select star from DB log. FNDB log is still executing. Many VLFs we are having. Oh, such a huge, some lakhs of rows are there in this table, I think so. Let's stop this execution. It's not much required for us. Okay. See, LOP begin checkpoint, LOP exact, it is trying to execute LOP end checkpoint, LOP begin checkpoint, LOP modify columns. Likewise, LOP modify rows. Again, LOP insert rows, LOP commit transaction. Likewise, it is showing some with respect to this VLF, the operation with respect to this VLF. Whether it is using heap or null, it is showing again the transaction ID, the log generation, and all the things it is showing. The previous LSN, at the end it will show you some important activities like I think these are all the partial status, nothing helpful here. Description, insert operation it is saying. It will describe this what kind of operation it is here again. Row log contents, it gives you some vast information about this and the log, whether the log file log type is compression or not. This is a log record. By using this, we can also trace. If you use some, it's like deeper knowledge, by using this log record information, also we can convert this binary to text and we can see what is the transaction related to completely in a deeper way. Okay. If I'm trying to execute this command, it will show you this log file information with respect to this database. Okay. If I'm trying to see if I see one, it will show you some amount of extent. See, There are some huge transactions in this database. It is showing it is taking some much time. See, the number of columns will get increased here. See, okay. If I am trying to say 2, again the number of columns get increased. Okay. If I am trying to say 3, it will show you as a FND below the complete information. Again the columns get increased. See, all the columns. Some huge amount. It means like this. If I say this parity level as set to 1, it will show you some amount of information. And if I set this parity level to 2, it will show you some amount of information with some more information. If I say 3, it will show you all the information, the complete information. Other than 3, we are not having any parity level. The highest parity level is 3. Okay. The query is still executing. Let us stop there because we are not having any. We do not require that information. Okay. Examining the log records we have completed and protecting the log file. How can I protect my log file not to grow completely, or how can I protect my log file because it should not stop the incoming transactions? How can I protect? It's like by scheduling a maintenance plan to have a log backup depending upon the transaction flow in your database. It means like I'm having many transactions that comes into my database. In that case, you just schedule a log backup for every 15 minutes. The incoming flow of transactions in my database are very slow. On a daily basis, I'll be getting only just 100 to 200 MB of data. And in that case, you can schedule a log backup for every 1 hour. If you're having some 500 MB of data per 500 MB or more than 1 GB of data, then in that case, it's better to schedule a log backup for every 15 minutes. Okay. And what you have to remember this one point in protecting the log file is like only one transaction log file is necessary in your database. Yeah, if you create multiple log files in your database, again it will impact the performance because what happens is log file writes the transaction sequentially. If you're trying to insert the data into multiple log files, what it will do is it will write 5 transactions completely into one LDF and from 6 to 10 into another LDF again. So it has to stop. It means it will not write the transactions parallelly into multiple log files. When you add some multiple data files, uh, the data will be written to the multiple data files parallelly, but not in the log file. The log file will follow the mechanism sequential writing because the log file transaction will have LSN number. With the order of LSN, it will write the transactions into the log file. Okay, into the disk, or it will flush into the disk or log cache. Wherever it is trying to write, it will follow the order of LSN. So, a random writing of transactions will not be allowed with respect to log file. Only sequential writing of transactions will be allowed with respect to log file. You have to remember this part. We can add multiple log files in our database, but it's not recommended. Only it is recommended when we are working with our databases with respect to some what we say GIS applications or likewise. Okay. We can also add some disk space when our transaction log file is running out of space and there is no option. We have seen that just now. And it's better to use some IO subsystems like SSD type of hard disk, like storage disks, like rather than using some SATA type of hard disk because it improves the performance and it means like the resolution speed, the writing capacity to this disk will be very fast when compared to the SATA hard disk. The SSD will be having some resolutions, highest resolutions to write disk into the disk. This may also improve the performance of the log file. Okay. And see, I'll show you practically how does my log file get will show the impact on the performance of my database, and when does my log file gets filled, and when does my log file will show nothing, when does my log file will show active transactions. Okay, let's create a database. It's better, I think so. We'll take a new window. Okay, let's create a database. Create. Sorry, it's already create database. I'm saying it's already there, I think so. Let's stop the database. Okay, be easier. It's a log test. Database is also having multiple transactions. It is taking mistake. It is currently in use. Somewhere the transactions are getting executed. So where it is in use, where it is in use, nowhere it is in use, right? Okay, let it be. Let's stop it. Okay, create a database. L test. Okay, I'm trying to use the database, trying to create a table. This database, not much more columns, only 3 columns and taking employee number integer as a data type, and employee name with can as a data type, salary of that employee with money as a data type. Okay, just trying to execute this. It will create a table and trying to insert some data into this table. Okay. Sorry, I have not written values. So that's why it is showing me that. Okay, insert into see here. It is only one row. Okay. And in this database L text, and if I go and see here, if I see the log space of this, okay, okay. The sessions are got disconnected due to that. It is saying our database is currently in use. Okay. See, L test 8 MB. My log file space is 8 MB, and Space used is 5%, 5.6%. Okay. Let's say DPCC login for it will show you the VLFs, number of VLFs. I'm having only 9 VLFs. So it is in master. We're having only 4 VLFs. Okay. Log read by description. It should say nothing. Red tests, nothing. Okay. The recovery model. You can see the recovery model. And test is full recovery. By default, whenever you create a database, your recovery model will be created in full because your model database will be in full recovery model. Model database is a template for any database that which you create. We'll in our next session we'll discuss about the system databases and what are the system databases, why we use a full recovery model, why only a newly created database will be in full recovery model. Okay, let's see now this BPCC login to the number of VLFs will be. See here, file ID is 2, file size VLF size is this, and start offset this plus this we have discussed now. And F sequence number is 34. My status, I have told you now, for each and every newly created database also at least one VLF will be active. Okay, the parity is 64. Create a lesson is 0 for all the VLFs because no auto growth was happened here. Okay, and what I am trying to do is I'll try to what I'll try to do is I'll try to add some more rows into this. Okay, setting to what I'll show. I'll just change the recovery model, alter database name, I'll test recovery. Let's see now. After changing the recovery model, select okay. It's better to have name because what database it is we have to know. Now my L test was changed to simple recovery model. What happens here is if I am trying to execute some insert into EMP is our table name, right? Just try to insert 10,000 rows at a time. And in that meanwhile, I'll try to show you, will show active transaction. Okay. Got executed. But in that meanwhile, if we see it will show you as active transaction. I'll just try to check where we are. Okay. I'll just try to insert 1 lakh rows now. See. Oh, not too much time. It got executed, I think. So, let's select this here. being executed, right? See here. Show active transaction. Okay, okay. Let it get executed. Until that log file fills, it will not show you as active transaction. Test is 18% only. Oh, we have executed in demo and we are seeing this as L test. Okay. My demo database is 100% filled. Okay. Here we are in L test here, and we are seeing demo. Sorry, nothing. Very good executed actually. Show me again. Don't get confused. As we are seeing practically, see L test is only 20% filled. Okay, it is 100% filled. Sorry, it will truncate the log file because we have not taken full backup. We have to take full backup first. We are in simple recovery model, it will automatically truncate the log file. Okay. But when you're trying to insert some bulk transactions and your log file space is almost filled, in that case, what it will show is your simple recovery model will show as active transaction. Okay. And I'll change my recovery model and I'll show you log backup the database recovery. Okay, recovery model to full. What I will try to do here. Initially, it's better to see what is the size of my log file. 20%, right? Okay. Mm, I'll do one thing. Create some more tables. Then I'll create. Try to insert some 10,000 rows into this table also. Write a union and I'll try to join all the tables by creating some 3 to 4 tables. No? I'm trying to insert 20,000 rows at a time. This table. it will get executed. And in our previous table, we are having 10,000 rows. This in this table, sorry, in this table we are having 20,000 rows. I'll create, I'll create another table. In that also, some, I will insert some 30,000 rows here also. What we are trying is we are just trying to increase the size of our log file. After creating this, before executing this, it's better to take a backup because we are in full recovery mode. It will be complicated because if without full backup, the log file gets truncated and it will never get filled. This table is 20,000 and this table is okay. This same. I have okay. Zero successfully. Better to take full backup because our log file will get truncated. But become 100%. Our sync will not reach our scenario like to show as log backup in case of the database. I will test and saying to this. Having a folder in E drive, backups folder in E drive, taking my log backup there itself. Correct. And database name, test to disk equal to hmm, what is incorrect here. Sorry. We are taking full backup and again what I will try to do is I'll also try to drop the table MP. Try to drop the table EMP. Here we have created this table EMP. I'm trying to create this table again. Trying to insert this row 1 lakh times. Okay. Create. Before this, we will see this is SQL for log space. We will see what is the log size of our L-test database. C is 15% used and 71%. Okay. And then see, I'm trying to create a table EMP I am trying to insert 1 lakh rows. Let it get execute here, and here after coming here I am trying to execute student table and executed successfully, and I am trying to insert 20,000 rows. Okay, let me do this activity in another window. I am trying to create table customer same database. I am trying to insert 30,000. Means we are inserting almost 1,50,000 rows, and definitely our log backup should get, our log file should get reached almost, it should reach to 90 or 100% definitely. And then we can see our scenario as log backup in select log reuse by description from system databases. Because if your log file gets 100% filled and you are in full back in, you are currently in full recovery model, and you are not, your log file will not get truncated until unless you take log backup. But whenever you are in simple recovery model, the log file gets truncated uh, automatically, because truncate on checkpoint is enabled in simple recovery model by default. We are aware of that, right? And here we are. This also got executed. I think 1 lakh rows also got executed. It's better, what we will do is we will just see the count of rows from our table, that which we have which we inserted now. Okay. It is showing only 1 lakh. I think the database is not in this. Setting to do. It is showing only 1 lakh. It should show 150, right? Oh, here 3 different tables we have inserted. Right. Okay, okay, okay. I will just try to do another activity here. What I will try to do is I'll create another table. Create table. Some, what I have to say, employee. I'll say employee ID, employee name, and care of 20, and salary. Sorry, I'm just trying to allocate the data from this create table. What I will do is I'll just try to insert all these tables data into this table. That into maybe insert into, sorry, employee, select star from EMP, union all, select star from student, okay, union all, select star from customer. It should have should get executed, but execute the same command. Why it is showing again error? Create table insert into employee. Sorry, it is the same. Let us see. Sorry. See, 1,70,000 rows got affected. If I say now, select star from employee, now select star asterisk count of employee. If I secure this, it will show your count as 1. And now I try to see my log file space. Now if I try to see my log file space, this L tests, we are into database L test. Oh, actually it is 59% only. We will see whether it is showing log backup or not. Log reuse, sorry, log reuse, score, description from start databases. Okay, see, we did not type name. See what my test is saying of log backup. Okay, if it is in simple recovery model, it will show you as just active transaction. That's it, it will show you. And in this case, in this case, what we have to do is now, either we have to take log backup, and my log file got 100% filled. And if there is any scenario that my database got went into suspect mode, recovery mode or suspect mode, recovery mode it will go. Most probably it went into recovery mode and I am not able to connect to the database. In that case, what I have to do is I have to add some disk space. And if there is any some space and unable to take log backup, okay, in that case, you can change the recovery model to simple. It will truncate the log file. Okay, if there is any space to take the backup, then you can take the backup. And after taking the backup, if you shrink the log file, then it will compress the size of log. Okay, and some other activity also we can see, like what kind of statements who has done by executing some commands. Okay, see, we have inserted. Okay, so this we have done. And see, select current LSN operation. We can see this. Okay, by using this command, by using this script, we can say, we can also verify that who has used some select operations, insert operations by using this command. So by using the script, we can see, see here, what is saying select from FNDB log, DB log, where transaction name like insert, okay, and allocation unit table name like employee. Shall we say employee? Okay. OS, which user has done that, it will show. It has to show. Just executing because some more rows are there. It will not take much time. Okay, let us see. We have inserted almost 1,70,000 rows in this table, uh, in this database. It is with respect to database, not with respect to, sorry, it is with respect to table, employee table. See here, these are all the insert related activities. The information is completely related to insert related activities. See, what some people will do is they will say that some people will do is they'll say after deleting a transaction also sometimes they will say that I have not deleted the transaction sometimes. We are also having for that reason also we can with respect to that scenarios also we can trace like who has deleted the rows like by using some these kind of bits. Okay. And in this session, we have discussed that what is a transaction log file, what is a uh, file ID, and how does the auto growth. I forgot to show you auto growth. See here in LTest database, we are in LTest database. Let us refresh the instance once. LTest properties and same properties. Okay. See files. See here. This is my log file and auto growth is set to 64 MB. In our earlier versions of 2012 or 2014, here it is by 10% or by MB by the size of in the size of megs also you can increase your auto growth, specifying the auto growth to in with respect to some amount of size by specifying 10 megs or 20 megs or 30 megs. Okay. Or if not, you can also increment your log file with 10%, 20%. But from 2016, there is a new feature that Microsoft has increased. Your log file and data file will get your log file and data file auto growth will be 64 MB by default. Okay. And where we are. Okay. This is all about protecting the log file, and we have seen that activity like log backup activity. Okay. See here, if it shows like we had seen somewhere instead of showing log backup here, if it is showing database mirroring, the problem is with respect to mirroring activity. If it shows replication here with respect to the database name, log reuse where description is a replication, the problem is with replication activity, high availability scenarios. And if it is with respect to always on availability group, the problem, the log file is the log file is facing problem with respect to that always on availability groups issue. Okay. And see new features with respect to log file in 2014 and 2016 here we are saying. Write log wait type. You're not aware of wait types, I think so. In SQL Server, we will be having wait types. Okay. Wait types in the sense when your thread, when a, when a thread is allocated to a transaction and your thread will be in running to runnable state. Okay. Allocating before allocating and suspended from suspended to running to runnable state. In that process, in that runnable process, your threads will be waiting because that thread should get executed. That process, in that process, you are having some multiple wait types in SQL Server. That process is called waiting time. It means like wait signals we have discussed in our database SQL Server architecture session. In our SQL Server architecture session, we have discussed about this like the wait signals or wait types. Those are all wait types. In 2016, we are having almost 800 or 900 wait types we are having, and in 2019, it is like 1040 we are having. Select transistor dm underscore os underscore wait underscore stats. This retrieves our complete weight count of weight statistics weights in 2016. Retrieves 877 we are having in 2016. In 2019 we are having 1040 weight types. Okay. And what is right log weight type? Why we are discussing about this right log weight type now? Okay. See, whenever you're trying to write a transaction into the SQL server, what SQL server will do is SQL server will take the data, and after you're writing some transaction, you're trying to do some changes on your database, or you're trying to do some activity on your database in the SQL server. What it will do is initially it will write those transactions into the log cache. Okay. After writing those transactions into the log cache, what it will do is it will not write directly to the disk. Okay. It will not write directly to the disk. What it will do is not to the disk, sorry, it is writing to log file. Here also it is not writing to disk, sorry. It will not write directly to the disk. Okay. What it will do is it will write those transactions into log file, and from there to disk. Okay. From there it will write those transactions to disk. Okay. In that meanwhile, your transactions are being wait. Means like there is some latency from log cache to transaction log file. Your transactions are being wait. This wait type is referred to as write log wait type. It means like the data delay is being occurred with respect to the occurrence of this write log wait type. But if you are not having this wait type here, and if you are trying to write, if you are trying to write mm, the data from log cache to transaction log file, then you will have some, it means like you will have some performance related issues, because you are holding some amount of data in log cache, some amount of transactions in log cache, and you are releasing some amount of transactions to transaction log. Both are in working process, and your working procedure is not being stuck anywhere in this case. What SQL server is doing is that to avoid this kind of wait type, what SQL server is doing is it introduced a concept called transaction delay durability in 2014. This is 2014. This was introduced in transaction delay durability. You can set this transaction delay durability. It's like a database property, I think. It's a database property only. We'll see. Sorry. Options, not options. Yes. See here you will have update statistics, update string, auto string. Instead, See here we are having delayed durability, disabled, allowed, and forced. Okay. If you're saying delayed durability is disabled means, it means like you are in earlier version as SQL Server 2012 where it will stop the transactions. Okay. If it is allowed means on or off you will be having allowed. Okay. If you are allowing, but you need to have confirmation with your customer, because if you are trying to allow, if you are trying to allow the transaction delay durability, you will not have write log wait type here. It will directly write the transaction log into the transaction log file directly. Okay, write log wait type will not occur, and it will not write into the log cache, I think so. Wait, I'll get confirm to you. Sorry, I'll get confirm about this. Yeah, here we are having a right log wait type here, and what we are saying is that why right log wait type means SQL Server should follow ACID properties, atomicity, consistency, isolation, and durability. To maintain durability, it means to obey the durability level of ACID property, rule of ACID property, is what SQL Server is doing here. Whenever we are trying to do some transactions on SQL, the log cache will store those transactions in that, and before writing, it means like my transaction log is not completely filled and it does not flush the transaction to the disk, flush the logs to the disk. Okay, until my transaction log plus some amount of transactions to the disk, these transactions will be in a waiting process called write log wait type with respect to write log wait type to maintain some durability. Okay. What transaction delay durability is saying that to avoid this kind of write log wait type, to improve the performance of in SQL Server with respect to this write log wait type, we are having a transaction delay durability. It means like without waiting here, it will just what it will do, transaction log file directly writes plus the data into the disk without waiting, and no waiting process here. To implement this kind of activity in our database, we have to set our database delay durability to allowed. Allowed in the sense, it means like what you have to understand here is the dirty pages are also being written to the disk, not the clean pages. Okay, uncommitted transactions or some, you will be having some data loss here. Okay, it means like some blocks, it means some, if you are having one block within that span of time, 60 KB of block, you're aware that the block size is 60 KB, right? 60 KB of amount, 60 KB of data will be lost here. To accept, when your customer is ready to accept some amount of data loss, some portion of data loss you will be having. In that case only, this delayed durability option should be in allowed. It should be enabled as allowed. It means when you say forced, it will be used when it want to use, only in some cases. Okay. This is a new feature in 2014 with respect to log file, and in 2016 there is only one enhancement in 2016, like auto growth option. They changed this auto growth option from, initially we are having an ability to change the auto growth with respect to size, like 10 mix or 20 mix, 20 mix or 10 mix or 30 mix, or by percentage like 10%, 20% or 30%. But from 2016, what Microsoft is saying that by default, we are only increasing the auto growth from to 64 MB for MDF and LDF for both the data files. Okay. And here ends, we have almost we have covered all the topics with respect to log file. This is a summary. You should be able to know what is a log file. After this session, we have discussed all this. What is a log file? How do we have to verify a log file incrementation? It means like auto growth. What is happening when we commit or roll back a transaction? It means while committing a transaction, it is using first in first out mechanism. While while doing a rollback transaction, it is using last in first out uh, mechanism. States in a log file we have seen like active, inactive, reusable, passive. How many VLFs are being created in a log file? We have to discuss this point, Avi. Okay. In what we are saying, it's like if your log file size is 64 MB, 4 VLFs will be getting created. Okay. If your log file size is 128 MB, you will be having 8 VLFs will get created. And if your log file size is in between 128 MB and 1 GB, you will be having 16 VLS will get created. If you are having 64 MB of log file, then 4 VLS will get created and 1 VLS will be 1/4 of your log file size. 1 by 4 into 64 MB, the maximum VLS size can be of 16 MB. Okay, if your log file is having 8 VLFs, each VLF size will be of 1 by 8 into your actual log file size. And if your log file size is 1 GB, 16 VLFs will get created. 1 by 16 into again 102. Okay. And in 2014, you are also having some new features like with respect to these VLFs. Okay. In 2014, the creation of VLFs were changed. It means like see here, up to 2012 less than 1 MB, up to 64 MB, 4 new VLFs will be created, roughly 1/4 the size of the group. To 64 MB, not 64 MB to 1 GB, sorry. It is not 512 MB, I'm saying. 1 GB, it is 8 VLFs get created and each VLF size will be roughly 1/8 the size of our log file. Okay. It means like if your 64 MB greater than 64 MB and your log file size is 800 MB, right? Your VLS size will be 1 by 8 into 800 MB. It is what Microsoft is saying. Your VLF size will be roughly 100 MB, each VLF size. Okay. If it is more than 1 GB, 16 new VLFs will get created. But in 2014, before 2014, 3192 VLFs were got created with respect to this some mathematical calculations like 1 by 16 like that. 3192 VLS got created. Okay. But from 2014, they are reducing like to only some few VLS will get created in 2014. Only 455 VLS will be getting created from 2014. And it's like improving the performance of log file. That's it. By reducing the VLF size, VLF count. Okay. And in 2014 only, delayed transaction durability process was implemented. This is the URL that if you want to study, you can use this URL to know about this delayed transaction durability. Okay. Hope I am clear up to this point, and we are much flexible about this transaction log file now. If you are interested, I'll show you some questions also with respect to this transaction log file, because transaction log file, right? Some questions that you need to know with respect to this transaction log file. I'll show you it. This one. Yes, I've prepared some questions. Okay. Sorry. I have prepared some questions. Transaction log. See, what is the necessity of a transaction log file in order to keep your transaction log file to a manageable size? what should be done, how do we can see the log files for all the databases, and I'll send you this document and you please go through this document, and if you're not being able to answer these questions, what you just try to do is you just I'll share this recording to you, and you just try to see uh, whether you are being able to answer all these questions or not. And if you're not being able to answer this question, you please let me know. I will